Hey guys, how are you? Welcome back to the channel. Today is day 37 of Upskilling myself, and today was the most productive day that I ever had. I solved 4 DSA problems and did the revision of like many stuff. I did the revision of AWS, I did the revision of back end and front end, and also did some internship work. So yeah, let's see the DSA problems that I solved. And one more thing that I bought a new mic. So please comment down if you like the new mic or the older one was fine or not. Okay. So the first problem was search insert position. So we have been given an array, let's say 1, 3, 5 and 6, and the target is given as 5. So we have to find the position where we can insert this target, and the array will be in increasing order, right? It will be sorted. So in this case we can insert 5 over here, or we can also insert over here. So we have to return the smallest position, right? So it's like this is the 0, 1 and 2, so we have to output 2. In this case we have to insert 2 in this array, so we'll insert on the position 1, and we have to solve in O of log n time complexity. So whenever you see O of log n, so you should recognize that we have to solve using binary search, mostly binary search, right? So we define n as the nums of size, then we define start as 0 and is n minus 1. We do the basic binary search, like when while start is less than equals to end, we'll get the mid. If nums of mid is equals to target, we'll return the mid. If nums of mid is less than target, then we will increment start, else we will decrement the end, and then we'll return start. So it's basic binary search. I guess you all know this type of basic stuff. So the second problem is linked list cycle 2. So we have been given a linked list, and we have to find whether there is a cycle in the linked list, and if there is a cycle, we have to return the position from where the cycle begins. Okay, so in this case 2 is the position where the cycle begins. So this is the cycle and the position of 2 is 1, so we have to return the position. So how to solve it? So we set slow and fast pointers. So we use slow and fast pointers. So slow will be over here in the start, and fast will be also over here, and fast will be incremented by 2, that it would be advanced by 2 positions, and slow will be advanced by just 1 position. Okay, and then if slow and fast are equal to each other, then we just have to return the position. Okay, if there is no head, then we have to return the null pointer. Then we will define slow and fast on head. Then while fast and fast of next is there, we have to increment slow by 1 and fast by 2. Then if slow is equals to fast, then we have to set slow as head, and then again while slow is not equals to fast, we have to increment both by just 1, and then we have to return slow. Then after performing this loop over here, if we do not return anything, we have to return null pointer because we don't find cycle. Okay, the third problem was search in a rotated sorted array. So this array over here is sorted, but it's rotated. Okay, so if you see, let's take an example: 1, 2, 3, 4 and 5. So this is a sorted array, and rotated it means at a certain position the array is rotated. So it's like 3, 4, 5 and 1, 2, right? So we have to search in a this particular array over here. The target is 0. Okay, so in this case, if you see, we have to solve it in O of log n time. So O of log n means binary search. Whenever you see array and O of log n, you have to just blindly apply binary search most of the time. So how to solve it? So it's just a regular binary search, just you have to figure out which is the sorted side. Okay, so whichever side is strictly increasing, that is the sorted side. Okay, if the left side is sorted, then find if the mid is larger than start and greater than target. If so, then the answer lies in the left side, else the answer will lie in the right side. Okay, so we define n, we define start as 0 and as n minus 1, then we traverse the array, then we set mid, we compare. If they are equal, we return mid. If they are not equal and the sorted side is the left side, then if the nums of mid is greater than target and the target is greater than nums of s, that means the left side has the target for sure, right? So in this case, we will do the end as mid minus 1, else the start will be mid plus 1. Okay, and similar for the other side, right? And then afterwards, if you don't find the target value in the array, we return minus 1. The final problem was find in a mountain array. So what is a mountain array? A mountain array is something where this is the peak, the elements on the left are strictly increasing, remember the word strictly, and on the right side they are strictly decreasing. So if you see this 1, 2, 3, 2, 1, this is a mountain array, it's going like this. But this, in this case, 1, 2, 2, 3, 1, 2, sorry, 3, 2, 1, this is not a mountain array because it's going like this, and we don't want this over here, right? We want strictly increasing or strictly decreasing, right? So first of all, what we do is we have to find the peak, Then we have to do binary search over here and here, and then wherever the target is present, we have to return it. Okay, so to get peak, we have this function over here. It's pretty easy. You just check for the peak if the left side element and the right side element is less than the mid. Okay, then for binary search in the ascending order, which means for the left, we do the regular binary search. But just the thing over here is, if the middle element is less than the target, then we set the start as mid plus 1. Over here, the different thing is, if the middle element is greater than target, then we set as mid plus 1. Okay, then this is the main function to find the mountain array. So find the peak of the mountain array, which we already did. Then first check for the left side and then in the right side, and then using binary search for ascending and descending slope. Okay, so define n as the mountain array of len. Then we have to find the peak. Then we have to search in the left, and if the left is not equals to -1, which means we found the target, we return left search. Else we return the binary search of the descending, which is the right. Whether it returns a value or it will return -1, it doesn't matter. Then for the development part, I did a deep dive into backend. Like I'm revising every single topic of backend, as well as I'm deep diving into more harder topics. Then I did the revision of AWS, as well as try to implement some services. Then I did some internship work, and yeah, I had a lot of tasks to do. And yeah, I did the revision of all the DSA problems that I solved till now. So yeah, thank you guys for watching, and see you on day 30. And yeah, don't forget to leave a review of the new microphone. So thank you guys. Bye.